the mesh currents for the respective nodes we need to find out here. So this is the 20 volts power supply. We need to find out the mesh currents between the current loop 1, loop 2, and loop 3 we need to find out. So this is by applying the Kirchhoff's voltage law we need to apply. So let us consider apply the KVL for the mesh 1. So let us apply the KVL for the mesh 1. We'll apply the KVL for the mesh 1. So this is a mesh 1. We'll start from the power supply will start here. The current entering positive, leaving negative, it's a drop in the voltage. So with that concept, we'll start here, minus 12. And the drop across this one is it's a minus 3 into I1. And the drop across the 6 ohm resistor, since the two currents are flowing, one is I1, other one is I3. So let us take the difference of the I1 minus I3. So it is minus 6 into, it's I1 minus I3. And if you come to the 15 ohms, again the two currents are flowing. One is I1, other one is I2. So it's a minus 15 into I1 minus I2. It's a minus 15 into I1 minus I2. And the current entering positive, leaving negative, it's a drop in the voltage. So minus 30 is equal to 0. Let us simplify this expression. We'll simplify this one. So minus 12 minus 30 is there. So in the loop 1, it is 3 plus 6, 9 plus 15 is 24 ohms. So 24 into I1 minus this is loop 1 and loop 2. It's a minus 15 I2 minus loop 1 and loop 3. It is minus 6 into I3 is equal to the two voltages are there. It is equal to the minus 42 will get. So call this as equation number 1 here. So minus 42 volts, we'll call this as equation number 1. So similarly, we'll apply the KVL for the loop 2 will apply. We'll apply the KVL for the loop 2. So KVL for loop 2 will apply, or it is called as a mesh also we can call here. Both loop and mesh are one the same here. So we'll apply for the loop 2. So this is the loop 2 here. So we can start from the 9 ohms, or we can start from the 54 volts power supply we can start. So the current entering negative, leaving positive, it's raising the voltage 54 minus. So here also the current entering negative, leaving positive, it's raising the voltage. So plus 30. And here the drop across the 15 is it's a minus 15. And the two currents are flowing. One is I2, other one is I1. Let us take the difference of I2 minus I1. And let us come to the 30 ohm resistor. So here again the two currents are flowing. One is I2, other one is I3. So it is minus 30 into, so it's I2 minus I3. And let us come back to the 9 ohms. So it is minus 9 into I2 minus 9 into I2 will take here. So this is minus 9 into I2. And already we have taken the voltage source, 54 volts we have taken. So this is equal to 0. Let us simplify this one in terms of the currents. So here, so minus 15 I1 minus the drop across the I2 will be the 15 plus 30, 45 plus 9. So it is equal to the 54. So 54 I2. The polarity is important here. What are the sign we are going to consider? We need to multiply the terms respectively, and let us take the sign accordingly. So minus 30 into I3. So this is equal to 50 plus 30. It is equal to the 84 volts you'll get. Let us call this as equation number 2 here. So this is equation number 2 where we got here. So by applying the concept here. So we got the equation number 2 we got. So this is the equation 2 by applying the KVL for the mesh 2. Similarly, let us apply the KVL for the mesh 3 will apply, and we'll evaluate the terms here. So we'll go for applying KVL for the mesh 3. So in the mesh 3, we'll apply the KVL. So KVL for mesh or loop, both are one and the same here. So we'll apply the KVL for the mesh 3 will apply. So here, let us start from the 20 volts power supply. The current entering positive, leaving negative. It's a drop in the voltage. So it's a minus 20 volts minus the drop across the 30 ohm resistor will be taken as, so minus 30 into the two currents are flowing here. One is I3, other one is I2. So let us take I3 minus I2, and the drop across the 6 ohm resistor is, so it is minus 6 into the two currents are again flowing here. One is I3 and I1. So I3 minus I1 is equal to the 0 will get. Let us simplify this one by using the concept here. So in the loop 1, the value is it's minus 6 into I1. In the loop 2, we have the resistance common with loop 1 is it's a 30. So minus 30 into I2, plus in the loop 3 we have, so 36 into I3 is a, so this is equal to the minus 20. So call this as equation number 3 here. So we got the three mesh currents we got here from the equation 1, equation 2, and the equation 3 we got here. Now what shall we do is we'll represent this in the matrix format, we'll represent here, and we'll evaluate the terms here. So we'll go for the representation in the matrix format here. So what we'll do is, so in the matrix form, we'll represent. So from the equation 1, we have 24 minus 15 and minus 6 is there. So 24, we have 24 minus 15 and 6 ohm is there. So this is from the equation 1, minus 15 and minus 6 is there. This is from the equation 1, and from the equation 2 we have, so the representation of matrix form will make us to get the values clearly, and we'll come to know that which are the terms are not there, which are the terms are not there, we'll come to know exactly. That's why it's a better way, it's a good practice to represent in the matrix format. So from the equation 3 we have minus 6, minus 30, and we have 36 is there. So represent in the matrix format here. Now the mesh currents, we make it as another column matrix here. The value is I1, I2, and I3. So these are the three mesh currents, and the corresponding voltages we are going to represent here. So the voltages are minus 42. The corresponding voltages are, it's minus 42, 84, and minus 20. These are the corresponding voltages we'll get for the any equations. Now what shall we do is, in order to find the value for the I1, I2, and I3, we'll go for the Cramer's rule. We can go it here. Let us take the calculator and let us evaluate this one. So in the calculator, again, we'll go for the same steps. We'll go for the mode. So in the mode, we'll go for the select the solving the equations here. So in the solving the equations, we can find out the number of unknowns will be taken as 3 unknowns we'll take here. Let us substitute in the calculator. So the value for the first one is 24. Next one is minus 15 and minus 6. And the value for this one is minus 42. And for the second equation, we have minus 15 and 54 we have here. So 54. And again, we have minus 30 is there. And the value for the voltage is it's 84. And from the equation 3, we have minus 6. So minus 30 and 36. And we have the value for this one is minus 20. So if you are going to simplify this one, we'll get the value for the I1, I2, and I3. So in terms of the Cramer's rule, we can find out like this. So it's a delta 1 divided by delta. So delta 1 is the thing, it's a cofactor of this determinant matrix, and delta is the thing, it's a determinant of the matrix. So this value will become equal to so we'll get 0.119 amperes we'll get here. And the value for the I2, so it is equal to the value for the I2 is equal to so it's a delta 2 divided by the delta. So where delta 2 is obtained by, so this is replacing the this one with the values here, and we'll get, so the value for this will be, so the I2 will be the 2.04 amperes we'll get. And similarly for the I3, so this is obtained by delta 3 with the delta. So delta 3 is nothing but replacing the last column elements with this corresponding elements we can able to obtain. So that value is equal to the 1.468 amperes we'll get. So these are the different mesh currents we can able to obtain from the by using the mesh current analysis. And if you want to verify, we can substitute the value for the I1, I2, and I3, and the we can able to obtain the expression for the verification. We can do it here. So like this, we can obtain the mesh current. Similarly, if you want to find out the power dissipation in the any part of the network, for example, assume that we need to find out the power dissipation in the assume that we need 9 ohms here. We need to find out here in the 9 ohms the current flow in I2. Let us find out the power dissipation. Already we have seen that one. So the power dissipation in that one is, so the power dissipation in the 9 ohm resistor. So it is P9 ohm, which is equal to the I square into R. So I square into R, the value for the I square is, I think it's I2 current is flowing here. So it is 2.04 the whole square into the value for the R is 9, so that we can find out the power dissipation. So in the calculator, we need to change the mode. So let us find out 2.04 the whole square. So we'll do it. So into the resistance value is so it's 52 watts of the power is dissipated across the in the 9 ohm resistor. So this is how the power has been dissipated in the 9 ohm resistor here. So like this mesh current analysis will be helpful for us to find out the values for the how much power has been dissipated